45 minutes between layers, so it's real easy to deal with. Now, the next step is what we would call a fill coat, because we're going to start filling in undercuts and problematic areas that might cause a mechanical lock. We're also going to build a cut seam if we need one, which we'll talk about in a minute. But let's talk about undercuts, all right? So this is something you actually want to identify before you start the process, right? You don't want to be making this, halfway through the process and not have planned accordingly for an undercut. Undercuts are kind of hard to visualize on Mozart here, but you can kind of see where I've thickened up the rubber and packed it with kind of sculpted in like frosting a cake. We use a product called TxTPEG to do that. It is a little thixotropic additive, which is a fancy word for thickener. You mix that in a few drops at a time into your A and B when it's mixed together, and until it gets the consistency you want. And you can add enough to where it becomes like cake frosting, and then you can kind of pack in those undercuts. But to show you what a better undercut, a more significant undercut would be, let's talk about if we were making a brush-on mold of a skull, right? This is a much smaller one. But let's say you're brushing on layers of rubber and you're trying to build up this, uniform 1/4 inch thickness over this model, right? So the rubber goes into that eye socket and out the other side of that eye socket, and then you go to put your shell material on and it flows into that eye socket and it mechanically locks in place, right? And so let's show a cutaway of that. So this is a brushed on mold of a mold like that. Let me zoom in a little here. We brush on mold of this, and you can see we've got our roughly 1/4 inch layer of rubber. We cut this away, 1/4 inch layer of rubber, and then that shell material has flowed into that eye socket shape. It's also flowed back behind here. We've got this solid, this thin layer of rubber, and now that shell material is locked in place. We wouldn't be able to remove it without cutting it or busting it up into pieces. So that's a pretty significant undercut. But when we thicken the material up and pack those undercuts full, see we pigmented it black in that layer. We've now filled that undercut back here, so we've got it pretty much taken care of. We filled in the eye socket, we filled in that, and so we've just got this nice smooth, transition there, and that prevents those mechanical locks from happening. That makes sense? So let's go ahead and zoom back out here and I'll show you in that finished skull mold kind of what it looks like. So this is a well-used mold we're going to use again here in a little bit. But you can see the outside of this mold is relatively smooth. There's no big, deep pockets or undercuts or anything that's serious. But when we open it up and invert it, the eye sockets are solid chunks of rubber, right? We've got a solid chunk of rubber back in the back there, along with the cut seam is. So that's what we need to address. You need to make sure you identify when you're making a brush-on mold, and so you don't lock the material, the object into the mold in that process. Okay? Put those out of the way. The other thing that you're going to address in this layer is a cut seam, and if you need a cut seam or not. So something simple like say we're making a brush-on mold of the kryptonite we were talking about earlier at the start of this. We're making a brush-on mold of this guy. Say it's got a 3-foot tall version of this, big old giant crystal for some environment you're building, but you need to repeat it several times. Do you think you need a cut seam for this mold? You really don't, right? So it's basically a big cone, so the rubber will stretch and just kind of peel off of that. We don't need a cut seam in the block mold for the miniature version. It'll just stretch enough and we can pop the part out. But you get to something like Mozart here, you got this very narrow base and very wide shoulders, and the rubber will stretch. It'll stretch a lot. It might stretch over that a few times, but eventually it's going to be too much and the rubber's going to tear. And so what we're doing by putting a cut seam in is putting that cut seam where it's going to have the least visual impact on the piece. So if we put that cut seam, right up the surface here, or it tears on the surface, like the focal point of the model here, where everybody's looking at it, it's way harder to clean that up on all your castings, and you're going to have a really bad time. So we want to plan that and put that cut seam somewhere like on the back here, where it's going to have the least visual impact because it's not the focal point of the part. and it's going to be more easily sanded and cleaned because it's a smooth area on the back, and it's kind of the wavy area in the back of the hair here where it's easy to hide as well. So you want to kind of think about that, where it's going to have the least impact and where it's going to be the best spot to put it. Now, we also want to make it thick like this. We thicken it up and kind of sculpt that in place so that when we cut it, we have a more rubber that can be clamped together in the shell to make a tighter seal, so you don't have a mold that leaks as bad. Also, when it's got more rubber, it can kind of key together better and stay better lined up, and you won't have as bad of a flashing line. Because no matter what, you have a two-part mold or a cut seam, there's going to be a flashing line. I may be able to hear my finger going over that line there, but we would need to clean that up. So the less serious you can make that, the better. And so planning that cut seam ahead of time is highly beneficial. Okay. So when it's tacky, but it doesn't come off with your finger like chewing gum, you're going to be ready for that next coat. So let's go ahead and zoom back out a little bit here. And at this point, we're going to be adding just another print coat. This time it happens to have a little bit more blue pigment in it, but we're just building up layer thickness at this point. After that, when it's tacky, it doesn't come off with your finger like chewing gum. I'm going to put on another final coat, usually about 5 layers in this case, and start building let it cure and then start building your support shell. So there's different ways of doing a brush-on mold with a support shell. The most common traditional way of doing this is to take clay and sculpt it, in a divider line where you want that piece, that shell to separate. And then use some more clay, which we've got here, to buttress that up. Now, this has been banged around in my travel box and people putting their fingers in it, so it doesn't look very great. But you create that clay wall, and then you would mix your shell material. In this case, we use Plastipaste, which is a fiber-filled plastic shell material that we sell. You mix that together and you kind of trowel it up against that wall, right? So you usually use like the stick you mix with and kind of sculpt it in place. But you need that wall because this stuff's going to have like the consistency of runny applesauce. And so you have to have that barrier to get that nice divider wall where everything's going to line up, and you'll be able to put bolt holes through it if you need to. And then you would peel that clay off and apply some release agent. Usually Vaseline or thick paste wax is really good for on the shell material. And then you would sculpt the other half up against that, right? So that's the old school method. It's kind of the method you would use if you're trying to save money and use plaster, for example. If you're going to use a thick plaster and try to do that, you would need to build a divider wall as well so that you have a good seam line. I don't like doing all that. We have a material I prefer over that, and that is our freeform air. So the freeform air is a 2-part lightweight epoxy dough, which is also useful for the sculpting in and of itself. But you mix that dough together, part A, part B, and you can literally sculpt it in place like Play-Doh. So you can then put gloves on, you sculpt it, and you can smooth it with alcohol, and you can just sculpt that seam line exactly where you want it to be. So that's really handy because it takes away all the work of doing this clay layup and gives you just this nice, ready to work with material. It hardens up overnight. And then again, you apply some release agent to all those edges where it's going to touch itself, and then sculpt it or mix it up and apply that other half to it, right? And that's, making a mother mold. Now, you're going to let that cure overnight, and when you come back in, it's not just going to drop open like that, all right? There's going to be a babble involved in this process, okay? So anytime you made a mother mold with a shell like this, you've created a vacuum in between the shell material and the rubber, okay? So you have to break that seal to separate the molds, and it can be really a big fight to do that. So what you're usually going to do is get a few paint scrapers or pry bars and things like that. You're going to kind of wiggle your paint scraper pry bars into that edge there and start prying on it. You're going to listen for a sound, suction breaking kind of a sound. Sometimes it takes a couple pry bars, a couple scrapers in there to kind of pry on that. Sometimes you kind of leave one in one spot, start in another spot, and eventually you're going to go, and one side's going to break loose. All right, and then you can take something like a wooden sculpting tool or a popsicle stick or a mixing stick and kind of shove it in between the rubber and the shell material to kind of break that suction on the other half and then separate that apart, okay? So that's removing it from the mother mold. Let's quickly talk about the cut seam. So there's different schools of thought on how to do a cut seam. So a traditional way of doing that is to just cut with a sharp blade, fresh X-Acto blade, and cut at alternating zigzags up and down as you go. And that creates a really tight keying effect as those zigzags basically lock together when you put it back in the mold. But each one of those zigzags creates a tear point, kind of what we got going on there. It's where I kind of messed up my, alternate method. And each tear point, the rubber wants to continue on that like a zipper. It's kind of why we thicken up the rubber on the cut seam as well, is because it's more resistant to tearing along that cut seam. So, if we're not careful up here, we can keep ripping this and it just rip the mold in half. So each one of the diagonals becomes another tear spot. So what I like to do instead is to make a rolling S-curve. You see I got in there with a sharp blade and I twisted the blade back and forth as I cut to kind of create that curve, and that keys together really well inside the shell. Doesn't leak as bad as a straight cut would, which you wouldn't want to do, but also minimizes the tear points, if that makes sense. All right, we peel that off of our model, and then we would drop that back into our support shell, line it all up carefully, and put the other half on, and make sure the seam line is lined up. And in this case, we could put some rubber bands around this, or we could have drilled holes and bolted the thing together, like the skull mold we're going to use here in a minute. And that's the quick overview of brush-on molds. Again, you may or may not need to use that, but it's good information to have. And if you haven't deduced already, the reason why we're doing this in all these layers is so that we're not going to trap a bunch of air bubbles on the surface like that Texas mold we're looking at, where all these air pockets are going to be a problem, right? So that's why we do this in layers and build it up slowly over time, right? So that's the brush-on molds. Let's pull all those away, get them out of there. All right. Now let's go ahead and open up our molds we made because they are ready to go. Let's start with our duck mold. Zoom in a little bit for that for y'all. Okay. Now I'm going to go ahead and take the paint scraper here, and I'm going to cut that clay. It's not very sharp, so it shouldn't cut a rubber. I'm going to peel that away from the surface, and I can save these already rolled out slabs of clay, especially if I'm going to make the same mold a couple times. Then it's ready to go, and I can just kind of join that back together rather than mashing it all up and tearing that up. It can always be rolled back out, but it's work. If you can save that stuff and have it ready to go for the next project, that's awesome. All right, so you see it's stuck to the board. We need to separate that. Let's see. You can make cut seams in a rubber mold like this as well if you need to. Thankfully, this duck, actually, we don't have to have one. The rubber is flexible enough that this part will pop out. Some pieces might be too complicated. Like if you have a figure, with like 4 legs that's sitting there, and you got to get all these pieces out. You might have to make multiple cuts to separate between each leg of that part, and so it might have like a cut that kind of splays open 4 different ways. It just depends on the project. But yeah, you sometimes do. In the case of our duck here, you don't actually have to cut it. So I'm gonna go ahead and pick the clay out of the vent hole there, right? And I'm gonna pull the straw out. So that clears out. We have a nice, we have our ventilation hole there in the mold that's clear. And then to demold this, you just stretch the rubber and pop our duck out, right? And so we have our negative impression of our positive original model, and this thing is ready to make a casting in. Okay. So let's go ahead and do the same thing for our bigger molds that we made. Zoom out for that so it's bigger. So it's back into place. So we're going to go ahead and remove our clamps. Put them away. Over them. And then I've got some clay that I had mashed down to make sure that those boards didn't move around while I was doing the layup there. And then we just pull those loose. And those can, of course, be reused over again. These are not a product that we sell or make. You know, there's something that are, you know, like a DIY item. You know, you make them out of melamine board. These happen to be really fancy ones that they sent us from Smooth On that they made in their fab lab for out of like really hot, thick polypropylene board, the high density polyethylene. Kind of overkill, but they do work. And then when it's time to open this, we're just going to pick a corner and we're going to peel this thing up like that. And we've got our mold. It's ready to go. So I'm going to go ahead and get some of this stuff out of our way here. Pull this clay off of here. It's not, there's the little bits and pieces that are going to kind of cling to the rubber. They're not bonded to it. It's just kind of a static charge of the rubber that we're fighting in this case. But that will eventually kind of all come off the rest of the way. These guys out of the way as well. All right. These two molds are now ready to cast into. So I'm going to do a couple different casting resins, just make a couple solid castings just to show you kind of different examples of different options. So first we'll cast the Egyptian plaque here. You'll see that in the zoom in on that, see the detail. You can see it's now a perfect negative impression of that model, and that's ready to be, you know, poured in resin. Okay. Zoom back out. All right. For this demo, I'm going to go ahead and put on some fresh gloves. These are, by the way, these are nitrile gloves. I kind of didn't mention it earlier, but when you're making a silicone mold, you do not want latex anywhere near the rubber, right? Latex contains sulfur, and it will prevent the silicone from curing if you're wearing latex or have latex anywhere near it. So that includes latex balloons, anything with a sulfur content. The fumes off of it can inhibit the silicone from even just being nearby it, okay? So even a box of, you know, nitrile gloves, or sorry, not nitrile, a box of latex gloves is nitrile, which are safe. But you have a box of latex ones just sitting, you know, just 10 feet away. Sometimes the fumes off of that box can inhibit that rubber. So you want to make sure you're wearing nitrile or vinyl gloves that protect the expensive material that you've invested in. All right, so I'm also going to put on eye protection, which you won't be able to see, but eye protection, because we're going to start mixing casting resins. Now, the silicone we mixed earlier is pretty thick material. We're calling it pancake batter. That's a pretty good analogy. And stuff like that doesn't splash very easily. I'd be thoroughly impressed if you managed to get that in your eyes. But the smooth cast we're going to use next, I don't know if y'all can hear that, it's basically just a little thicker than water. And you have to shake these containers up to pre-mix them, by the way. Shake well before using. It's just kind of like our stir well before using. But these materials will splash very easily and then get in your eyes. And so you do want to avoid that because it's not good. It's not, you know, tears or air. It doesn't belong in your eyes, right? Okay. So for this, we're going to use Smooth Cast 320. This is a 1-to-1 mix, fast cure, just basic, relatively low cost off-white urethane. So it's going to kind of change colors to a warm tone white when it cures. We can add pigment to it, which we will probably do. If anybody wants to pick a color that we want to try to make it, we should type it in the chat. We'll try to make it that color, but we'll see how the color change affects that. Other thing I'm going to do real quick, because we're going to use a clear resin after this, I'm going to go ahead and shake that up too right now. Give it some time while we're doing this first casting to allow the air bubbles that are shaking to dissipate. That's the kind of the trick with this stuff. You don't want all the air that you should get into the material when you're using it. All right, so that's good. Let's go ahead and we're going to mix up a solo cup of part A, solo cup of part B. Get this out of the way. Open up this new gallon kit. It's going to have a foil seal we're going to have to cut open. Doesn't have to be perfect. Yep. And then when we pour the resin out of this, we're going to pour it at an angle, kind of like we're pouring soda into a cup. We don't want it to foam up on us. That sort of same idea will help minimize the amount of air bubbles you add to the mix if you're trying to reduce that. Now, we just shook this up so you can see all the air bubbles that are in there, and those are most likely all going to get trapped in that resin because we didn't give the material time after shaking it for those air bubbles to dissipate. So we're going to hopefully that'll be a little bit better in that clear resin since we shook it up and we'll put it aside. All right, so there's our part B. And same thing with our part A. Clean that blade off so that we don't cross-contaminate the A and the B into each other. Cut that seal, and same sort of thing. We're going to pour that at an angle. Did we ever pick a color? Anybody shout out a color in chat? I didn't see one. Orange, let's do orange, that'll work. All right, so equal parts by volume. So we got 8 ounces of, 12 ounces of A, 12 ounces of B. Using the solo cups as a disposable measuring device. Essentially, with the silicones, it's pretty easy to reuse the measuring containers. But with polyurethanes, these are moisture sensitive and sensitive to all sorts of other stuff. And so once you use this A cup, if you save that A cup and come back later or a couple days later, the A residue that's in there will have started to, well, in this case, the A will eat away at the cup over time, which is not great. But that residue will also absorb moisture and humidity from the air, and you can get a foaming reaction and contaminate the next batch of resin by that. So it seems wasteful, I know, but disposable cups like this are going to save a lot of wasted, expensive material by just getting fresh ones each time. Just keep that in mind. All right, so we'll put that aside, and let's get our bucket to mix this in. And let's go ahead and pour our part B into our mixing bucket. Same sort of thing, we're going to pour it at an angle like that, try to minimize the extra air we whip into it. Okay. Set that aside. Now let's mix some orange pigment. Is that what we're going for? This is our So Strong orange. Now these pigments get extremely messy. This one is, as you can see, it drips over it. Other ones in the drawer have dripped over it. It's very, very messy stuff. It'll kind of get tracked all over the workspace, things like that. Alcohol cleans it up pretty easily. You know, denatured alcohol, we highly recommend using denatured alcohol. It's going to be the bowl maker's best friend. Well, let's say we just put 1 drop in there, like that. And that 1 drop is enough if this were clear resin to give us that clear orange color. But this resin is going to change colors when it cures to a off-white color. And so that would be barely perceptible that there's even any pigment in it because it's just so little. So to try to get a deeper orange, we'll go ahead and add quite a bit of pigment. Now, the maximum load of pigment in this resin or any of these materials, is 3% by weight, which is a fair amount of pigment. So we're not really at risk in this volume of doing that. But if you're making really tiny stuff, I mean really tiny batches of material, you could easily accidentally over pigment. So you really need to be aware of that. But if you put too much in, it just won't cure properly. It might weep color out. It might, say, stay sticky or something like that. So it's just something to be aware of. All right, so let's go ahead and add our part A. Again, we'll pour it at an angle like that to try to minimize the extra air we whip in. And we're going to go ahead and drop that A cup into the B cup, because like I said, the A will start to eat away at that plastic in the trash, and then it'll react with the B residue, and that helps give a nice, keeps anything from dripping and leaking out our trash as those two react with each other. All right, so we're going to go ahead and get in here. We're going to scrape the side and the bottom of the container, mixing relatively slowly and deliberately. We're not going to go and whip a bunch of extra air bubbles in it. We're trying to avoid adding more air than is necessary. So scraping the sides and the bottom. And we're going to feel the side of the container with our other hand to make sure that we can feel how warm it's getting. So resin like this is exothermic. If you're not aware what that means, it means it generates heat as the part A and the part B react with each other. And so we're going to use that to our advantage. So this resin has a 3-minute pop life. That's 3 minutes at 72 degrees Fahrenheit at a very specific mass. I think it's usually supposed to be, that's measured at like 200 grams of material, which is not a lot. So the more you mix, the faster it's going to go because it's mass sensitive. So the bigger the volume, if you're mixing like 10 gallons of this at once, you have nowhere near 3 minutes because that's such a high mass, it's going to cut your pot life down to like 30 seconds. So you would want a slower resin if you're going to mix that much volume. And if you're working somewhere hot, you're going to cut your pot life in half. About every 10 degrees you go up from 72 Fahrenheit, your pot life's going to get cut in half. So if it's 82 degrees, you might have a minute and a half. If it's, if it's 90 degrees, you might have a minute. You might have, 45 seconds or something like that. So you want to keep that in mind. Climate control is your friend when it comes to these materials. Now this is getting pretty warm, pretty toasty. When it gets uncomfortable to hold, you're running out of time. You need to get your material poured. So we're going to go ahead and pour this in the center of our mold, kind of doing a long, thin stream like we were talking about earlier, letting it flow and kind of seek its own level. All right. Now you'll see, you may or may not be able to see, there are some air bubbles and stuff on that surface. It's kind of dark in that mold. What I'm going to do is to pop those, I'm going to take a little bit of release agent and just spritz it across the back like that. All right. I'm not spraying it into it. I'm just kind of spritzing across the back. And what it does is that particles in that release will land and pop those bubbles. And now you see the color change. That's the magic moment as it solidifies. You may also notice, and around the edges, it's still dark and it hasn't changed colors yet, right? So what that is, it's the mold rubber is cold. It doesn't exotherm, right? So it wasn't hot when we pulled it out. And so it's the cold 72-degree room temperature. And so it slows down the resin on the face where it's touching that. So that's the last part to solidify and change colors. It's not really a big deal for this material or most of our resins, but if you get into something like the crystal clear resin, it's our UV resistant water clear silicone, or not silicone, resin, urethane resin, it can cause a fogging effect on a glossy surface. So if you have a glossy model, but it comes out foggy, it's because of that slowdown effect. So you would need to preheat your mold in that sort of situation. Again, you're most likely not going to be using that stuff. It's kind of a toxic professional material that requires respirators and ventilation. These materials like this are much more UV friendly. Now this is still very hot and soft, but it's not sticky or liquid anymore. We're going to put it aside and kind of let it finish doing its thing while we do the next casting. Let's go ahead and cast our clear duck. Our duck mold. Drink water, I apologize. Some fresh gloves on. And get our clear resin that we were shook up a little while ago. So this is Smooth Cast 325. This is our what we call a color match resin. So it's a clear amber colored resin, has a very slight yellow tint to it, but it's pretty much clear. But it's easily pigmented. It doesn't change colors when it solidifies like this one did. And so if you need a specific color in your resin casting, you want this kind of a product so that you can pigment it exactly how you want it to be and predict it. This is hard to tell what you're going to end up with until you've done a test cast and you know, oh, I need way more pigment than I did, or I need to mix more of this color and that color to get the color I want. All right, so that's why we're going to use this one for the duck so that we can make it another color. What other color do you all want to make the duck? Anybody shot them out or types it out? Blue it is. All right. Let's go ahead and pour our part B. Now you'll notice I am pouring this out of this container sideways. And that is because that's how these containers were designed to work. Something I learned when I started working here and it blew my mind. If you've ever tried to pour alcohol or mineral spirits or other solvents out of one of these containers where the nozzle is in the corner, it tends to pour it this way, it tends to just shoot out of there and go everywhere. The reason it's in the corner is so that you can pour it that way and you can control the airflow and the material doesn't go all over the place. You might be wondering why this resin is in metal cans instead of plastic jugs like the other one. And that's because the resins are light sensitive. So if you're trying to keep a resin clear and not yellow on you, a metal container does not allow any light through, whereas this plastic does allow small amounts of light. And so if they packaged it in these plastic containers, you would have a yellower, more amber resin than what you do keeping it in the metal containers. So go ahead and pour that as well. That's our part A and our part B. Containers out of the way. All right, so we're going to make blue, right? So let's go ahead and pour our part B into our mixing container. And we're going to pour it on an angle like that to try to minimize the air we whip into it. All right, now let's find some blue pigment. Zoom in a little bit as well. Let's take, these are so dirty. All right, let's take a drop of So Strong Blue. Not going to take much. Let's do one drop. We might do 2 drops. So that's 1 drop of the blue. As we mix that in, you can see you get a pretty concentrated shade of blue there. All right. Now let's go ahead and add one more just so that when the A dilutes a little bit, we still get that sort of dark, deep blue. All right. Now, let's go ahead and add our part A. Again, we're going to pour at an angle so that we don't whip a bunch of extra air bubbles in. And drop that into our part B cup and toss it in the trash, because then the part A will eat through that and start to mix it. So it's kind of hard to tell or see at this angle, but they've stratified in here, right? So you can see the part A is sunk past the part B. We need to make sure we get all this blended in and mixed properly. All right, so we're gonna go ahead and like we were before, we're feeling the side of the cup with one hand, and we're scraping the sides and the bottom of the mixing container with the stir stick. We're mixing relatively slowly and deliberately. We're not whipping a bunch of air into it unnecessarily. And another thing while we're doing this, I want to talk about our stir sticks. So pretty regular problem we have is with our black resin. It's a jet black, solid, dark black resin. And when you're mixing it, you cannot see or tell how well it's mixed. You can't see any streaks of color or anything to know how well you mixed it. And we regularly run into problems with people coming in where they've got it oozing, gooing out, and unmixed stuff, and it's, they think the material's bad. We walk them back through the process, and we find out that they're mixing with something like a chopstick or a piece of wire, or any pencil or some round, thin object, something that doesn't have enough surface area like a popsicle stick or a stir stick does. And so they're not actually agitating the material enough, they're not blending it enough, they're not getting it mixed well. And so you need something with a lot of surface area, like a flat stick. In fact, even a spoon would be better than this piece of wire. But I would recommend something that you can scrape the sides with, like a paint stick. Now this cup's getting warm, so I'm going to go ahead and pour this material into our duck mold. Then we're going to pour in that long, thin stream. Let the material flow. And fill that up. All right. Now I've also got some excess. We'll just dump it in a waste mold here. This is just like a triangular planter mold that, it doesn't hurt to have an extra mold around. You're not sure how much material you need to use that to kind of get something out of it. So you can pour multiple layers of plastic in there and still get something from it. Now, an alternative to popping the bubbles on the back of this with the release is to use something like this trigger propane torch to just wick a flame over it like that, and that pops the bubbles, right? You'll notice I'm not holding the flame on it for a long period of time, because like most things, if you hold a torch to it, it will light on fire. You don't want that, right? So all we're doing is wicking that flame real quickly over it, and that just breaks the surface tension and pops those bubbles. You'll see this very commonly used when you're doing we have a product called tar bender, which is an epoxy coating for pouring over tabletops to do that clear plastic, like people do river tables and stuff like that. And that's where you need a torch to pop the bubbles. And the reason is if you do that, if you're doing multiple layers and you're spritzing release across the back to pop the bubbles, then you're going to end up putting release all over it, and then the layers won't stick together. So a torch becomes a much better option in that situation. But again, safety, pay attention to what you're doing. All right, I'm going to move this guy out of the way. Move this one out of the way. We're going to give those a few more minutes to set up. We'll come back to them. I mean, right now it is solidified. It's just rubbery and soft. We need a little more time. All right. I think we're going to do a slush cast real quick to show you making a bigger hollow casting. Fresh gloves. This is skull mold we were using earlier. We want to go ahead and make sure we assemble this thing properly. Now, this guy, I made it a few years ago, and I have done a lot of demos like this, in person with this mold. And so it's pretty well worn. You can see it's got a lot of crusties building up on the outside of it. This is kind of what you're going to expect from a mold that you use a lot, though. They're not going to stay pretty. They're going to get messed up, but it's still a usable mold. It's just broken a piece off here and there. It's still functioning, but it's probably towards the end of its real usable production line. We lined everything up in there, and that mold is ready to go. So if this is a solid three-dimensional skull, brush-on mold like we were talking about earlier, can you imagine if we poured that solid with resin, what that might cost? So a thin, object like we just poured, a small object like that duck is relatively, minuscule, but you get to bigger pieces. Say you were making like a cosplay helmet. You know, you're going to make a, you know, Master Chief from Halo, or you're going to make a Daft Punk helmet from the band. You don't want to pour that solid, obviously. You want that hollow so it can be a wearable helmet. Or in this case, we want to make a thin shell of resin, and we're going to back it with foam to make a lighter weight, less expensive casting. All right. But the process is the same for slushing, whether you're making a hollow part or a backfill part. So for this demo, we're going to use Smoothcast 65D. This is what a trial kit of resin would look like. You're going to open this up, and you're going to have, again, a technical data sheet and an SDS sheet. So save those, read those, check them over before you start with the material. You're also going to have all this extra paperwork on the part A that is just bonus, you know, regulatory stuff. They have to fit on the label, but they can't, so it has to go on there. So keep that in mind. Let's go ahead and take that off of there. Now, let's shake these up. You do have to stir well before using. In case, shake the containers up. And then we're going to get a little measuring cups. Open our part B. Get our foil cutter here. Cut that foil seal. We're going to go ahead and pour not that much part B. We're going to repeat that process for the part A here. And we got equal parts by volume again, all right? So I'm going to go ahead and this is going to change colors to white when it cures. So we can still add pigment to it and see what we get. I think we might do green unless there's any objections to that. I want to show mixing a couple different colors to get the green that we want. So what we'll do is we'll start with the So Strong green, or actually let's start with the UVO green, which is our UV resistant pigments. We got UVO green here. Needs to be shaken up actually. And this is going to change colors when it cures. So I'm going to put a few drops, about 3 or 4 or 5 drops worth of material in there. And it's going to get real dark, kind of a dark green there. See that? But it's going to be sort of a rich foresty green, which say we're not after that. We want more of a Kelly green or like a, you know, almost a really bright, vivid green. So we might want to add some yellow. So let's take some So Strong yellow here, which is also a messy one, and we'll add a squirt of that in there, a few drops. That's going to brighten up that shade of green, which we could have made our own shade of green, of course, with, you know, blue and yellow. You know, this color theory all applies to these pigments as well. If you don't have a pigment that's the exact shade you want, it's kind of why you have options. You can blend it yourself. That's all blended in there. It's kind of lightened up a little bit. Let's go ahead and get a mixing cup. Go ahead and pour my part B into that. Let's zoom out a little bit so you can watch what we're going to do next. That's all right. Zoomed out. Let's add our part A. And get the clock ticking. So we got another 2.5 minute pot wipe resin. We're going to have slower options of all of these. So for demos and small stuff, the fast resin is much more handy. So you don't have to wait for hours and hours to demold it. You only have to wait about 15 minutes. Also for a slush cast like this, a faster resin is generally better so that you're not having to keep rotating the mold for 20 minutes. You know, we only have to rotate it for 5 minutes or so. That's ideal. You know, you don't want to have to keep doing this longer than necessary. I'm going to go ahead and keep mixing this, scraping the sides and the bottom. until I feel it start to warm up in exotherm. All right. Okay, pretty warm. We'll go ahead and pour that into our mold. Mix it up. And you'll see, obviously, that wasn't enough to fill the mold, but that's kind of the point. What we're doing, we're going to start rotating this mold around to coat the inside with this nice thin shell of plastic. We could do this and make a couple layers like this and make just a hollow casting like a helmet. But in the case of this piece, what we're just trying to do is to make a lighter weight, cheaper casting. So rather than pouring this thing solid and spending, dropping $30 worth of plastic into it, we're going to use about $4 or $5 worth of plastic, or even less maybe, if we're buying it in a gallon kit, and put a skin of resin where we need it, and then we'll backfill it with an expanding foam that'll make a much lighter weight casting. It's still nice and durable. Now, we call it slush casting because we're slushing it around in the mold. There are machines that you can get or build that you can pour the resin in and close the mold up completely, and the machine will rotate the mold perfectly in every direction and give you a perfect hollow casting. We call that rotocasting. Humans are generally not good enough at this process to do it without seeing into it, to see what we're actually coating, what we're not, which is kind of why you're not seeing a lot, because I have to look in there to see what I'm doing. You can see it's kind of starting to turn green in there, trying to make sure I get all the sides and edges coated with resin. Now, this is also messy. It tends to drip like that, but you kind of want to wait till the end as the stuff starts to gel up to do that, right? So the 65D, we're using that for this resin for this demo because it's what we call a gel cure resin. It slowly thickens and gels over the course of that 2.5 minute pot light, which lends itself really well to this sort of a process. If you did this with that 320 or the 325 we did before this, that goes the clear and that off-white resin, what we would end up with is really thin parts and then a really thick chunk where the stuff solidified and flash cured in one solid part. You can slush cast with those. You just have to have exactly the right amount of material for the surface tension, of the rubber to grab onto it and not have, a big solid chunk somewhere else. And then you build it up in layers. Now this stuff is starting to thicken up. You can kind of see it pulling on my finger there. Okay, well, after this demo, we can go ahead and jump in and do mix up some epoxy clay real quick, and then call it done. Unless you really unless you need to end sooner than that. Up to y'all. I kind of planned for about 2.5 hours as usual, like class time, but we can cut it as short as y'all need to. All right, so that's good. And we can come back to that later and put some foam in it if we need to. Let's go ahead and open up our 2 castings from earlier quick. So there is our mold and our casting. Set that there. Zoom in real quick so you can see what those look like. There's our mold, a little bit of clay to fill in, and there is our orange Egyptian black. Yeah, you see it picks up exactly the same texture and detail as the original model had. This model was black and harder to see. All right. Now the duck may be problematic because it's going to have what we call a rubber stage. And so it may be really difficult to demold this without ripping its head off. We would ideally want to leave them in the mold a little bit longer. Let's go ahead and see if we can do it without tearing them up. So I'm going to try to be real careful. Kind of wiggle that head out very carefully. There we go. You can see our blue duck. Duck Gideon. Okay, that works for me. All right. Let's move these back out of the way. Let's go ahead and. Okay, that's fine. We can do that at 6. Works for me. So let's go ahead and while we're as we get closer to 6, let's go ahead and real quick and pour some foam in here. You can see now how it has changed colors to that bright green we were after. We've got that coating of plastic inside our mold that we're going to now backfill with some expanding foam. All right. So that got destroyed. Let's get a fresh one. All right, so we're going to back that skull with some foam at 4. This is a 1-to-1 mix, 2-part rigid foam. So these are some pretty well-used kit here, but we're plenty left to do this with. And you still got to shake the containers up. Go ahead and pour out some part B. Now we don't need a whole lot of material to backfill this skull, but I'm going to overdo it just so y'all get to see it go Mount Vesuvius and expand out of the mold and go crazy, right? So this foam at 4, it's going to expand, let's see, 14 times the volume that you pour. So we're going to get 14 times the volume of these two little bottom line of that cup. So this part A now has solidified. So this is the thing I like to show. So when you're using urethanes, part A tends to harden up and lock the lids on. So something like a pair of these channel locks is going to be your best friend if you're messy and you don't use these kits up quickly enough. All right. So a trick for that to avoid it in the future is to take some release agent, spray that under the cap, and that can help prevent that from locking on as badly. So we got our part A, we got our part B. Fight our cap back onto there. Put this out of the way. And we're going to get a large mixing container because unlike the resins we mixed earlier, foam likes to be mixed aggressively. And so we want to mix this stuff as violently as possible without making a mess. So we need a bigger container where we have enough room to do that. Go ahead and add our part A. And we've got about 30 to 45 seconds to get this stuff mixed and poured into our mold before it starts expanding, okay? So you can see me mixing real aggressively, scraping the sides and the bottom still. While it is fast, we want to make sure we get a really good, thorough mix. All right, it's looking pretty good. Go ahead and pour this into our mold. All right, and then y'all can see that. You can see that there. In there. We'll watch it start expanding a little bit. There we go. All right. So what we're pouring right here, what we're waiting on it to expand, is expanding rigid foam. So essentially this is a resin, kind of like we put on the surface here, what we've been pouring the last couple of demos, but it's reacting to water or moisture in the chemistry. You see it starting to rise down in there. And this is what happened to any resin if you leave it the part B or part A sitting open, it absorbs a bunch of humidity, or if you sweat and drip your sweat into it, or things like that. It won't usually get this nice and uniform. They've kind of engineered the foams to have the kind of the right working times, right amount of moisture content to get a nice uniform foam. But essentially all it is still a urethane resin having moisture reaction. So just like this is a rigid foam, it'll be a hard, stiff, carvable foam. There's also flexible foams, which this has got, this has a coating on it, which we'll talk about later, Uricoat, but this is a flexible foam, casting that is squeezable, compressible foam. So think like upholstery foam, with the foam that your couch cushions and whatnot are made out of. That's all going to be a flexible foam. Same sort of thing I've got going on here, which is a, zoom out just a hair. This is a piece of aluminum wire with foam around it that can then be bent and shaped in place in all sorts of ways. And so, that's another option there to think about. You can see our foam coming out. Any questions about the foams while we're watching that real quick? Nobody? All right. You see on this side, it's starting to kind of really push out. It depends on the foam. So we have a whole family of them, different numbers. This is our foam at 4, which means it's a 4-pound foam. That number represents how many pounds a cubic foot of expanded foam would weigh. So if you're to like pour a big block and cut a perfect cubic foot out, it should weigh roughly 4 pounds, right? So we have varying densities all the way down from 3-pound foam all the way up to a 26-pound foam. And basically the higher the number, it's like a 26, the lower the expansion rate. So that density is directly related. So a 26-pound foam, like our foam at 26, it expands about 2 times or 2.5 times the volume you pour. And then the 3-pound foam expands about 15 or 18 times the volume you pour. So you'll get finer detail in a denser foam, but you'll get lighter weight and lower material costs in a lighter foam. So it's all just variable. This stuff is mostly set. It's still a little rubbery. We'll give it a couple minutes before we start messing with it and demolding it. But while we're doing that, let's show another example of some close up on the grind there. Another example that's popular with flexible foams are soft foam props. So this is cinder block cast with the flexible foam, which I won't bother mixing because you can get the idea. It's going to be basically the same way. You can add pigment to these, and then you can, of course, this thing only weighs like 1.5 pounds, maybe 2 pounds, and it's compressible. You could hit somebody with it. You can still stack them and build them up if you needed to, and then have somebody run through a brick wall of them, that kind of a thing. So lots of cool things you can do with flexible and rigid foams. Now, this thing is mostly set up. I'm going to go ahead and trim that off before we demold it. So you can see where we mixed up too much foam. We now got this, awkward thing rising out of there. And so let's go ahead and trim that off before we open it. And we'll use a insulation knife, just a big fixed blade knife. And let's demold our skull. Now we will peel this guy open. It's a little soft. Just be careful though. You see we've got our Celtic skull flashing and everything, right? And he only weighs maybe, you know, I don't know, 4 or 5 ounces. He's pretty light. Zoom in a little bit, see it better. You can see the flashing where we have the cut seam at the top. I mean, then you can pick that, start picking that stuff away, clean that up. Now, obviously, it's kind of ugly on the bottom there. If this was your project, you're trying to make a nicer looking part, you would design it where you didn't put too much foam like that. You pour the foam where it only came up to maybe there, or if it's upside down, like foam only comes up to there, and then you pour resin and cap off that foam and hide the fact that it's got foam behind it. And it makes it a lightweight but very rigid and durable piece. You can see all that detail all fixed up. You'll see some bubbles and things like that. A lot of those are in the mold because this is a, what we would call a mold, I don't know what you would call it, but basically it's a mold of a casting. It's a casting from a mold from a casting from a mold from a casting. It goes back probably 10 generations. And so every imperfection gets transferred down the line if you don't fix that. So those are things to keep in mind when you're doing this sort of stuff. Always keep a master. If you're making production casting, make a master that stays perfect and you remake the mold off that master rather than the worst casting out of the mold after it's, you know, deteriorated. So it's 6 o'clock. You need to take a break for a second?
Yeah, because we're going to get some new people coming in.
Okay, no worries. Let me know. Do I have a favorite casting material to work with? I don't know, not really. I mean, it just depends. I've got preferred material, you know, take ones that I like better than others. There's certainly materials we have that are not as ideal as you might think. And so I'll, you know, let you know before you know, go that route. I might try to point you towards something better. But generally, you know, one of my favorite materials is that freeform air putty, which we were talking about for making the mother molds. It's just a very useful product for all sorts of stuff. Yeah.
All right, for those of you rolling in, the first 2 hours, these are 2 of the creations we walked through. And starting soon, we'll look at another little process, and the earlier things, I will post a link to a recording later once it processes.
So just to answer that question that popped up, the green skull is actually a rotocasted slush polyurethane resin. So we poured it into the mold and rotated the mold around to get a thin skin of plastic, and then we've backfilled it with expanding foam. And so I've left it all sloppy like this so you can see the foam in there, what we were talking about. But ideally, if this was a project you didn't want to have an ugly chunk of foam on the bottom of, you would pour less foam, expand it to there, and then pour resin off the bottom and cap that off and do a much cleaner job of that. But to kind of jump back in, if we're ready where we were, the expanding foam itself is a very useful material. So you don't necessarily have to use it in a mold as a backer or a casting itself, but you can use it, you know, as a sculpting medium. So you can carve it, you can pour a big block of it or a rough form block of what you're trying to carve, and you can carve away and shape this material. So those of you that are, you know, this is the themed environment class, right? So this is a pretty popular way of doing, you know, lightweight projects. So you can carve away at that. And then we can use something like, use a knife like that. And then we also have, or we'll have one, but popular choices would be to use something like a Sureform tool. Those are these basically cheese graters that are designed for shaping wood, but they work really, really well on foam as well. So you kind of smooth out the contour there. You can shave away with a Sureform tool. Works really nice. Or you can use these cheap rasps from Harbor Freight. and you can really carve away and shape and smooth and do all sorts of interesting things with it. So a common use that y'all may or may not be aware of. This is an example of a random piece that I carved for just an example. I poured a block of foam in a plastic tub, and then I carved away and shaped this sort of abstract form. And that, with that idea being in mind, you can also carve things like climbing holes. If you've ever been to an indoor climbing gym, those are the original models for those would be they make a block of foam, and a lot of them are going to carve away at that foam. And then this has been coated with a hard epoxy coating that we can use that gives it fills in some of the deep pores, and then we can make a mold of that and cast solid resin climbing holes, right? So that's a lot, and that also gives you that texture that's on climbing holes. It's that carved foam, right? That makes sense? So that's a popular option and something to keep in mind for carving foam. Now, that's where we're at here. I was going to show a couple more foam castings, since y'all aren't here in person to look at them. So as foam as a casting material by itself, you might be wondering, why are we doing the resin over the surface, right? Well, let's say you've got some architectural piece like this little mantle thing, right? This is a solid foam casting. You've got a mold that's got back pressure plate. That's why. So there's a board that goes off the bottom of the back of the mold. Pour your foam in there. It expands and it has some vents so that the material can escape. We cut those vents off there. This gives you a solid foam casting. However, foam isn't, especially a lightweight foam, isn't all that durable, and also doesn't like to necessarily fill in fine details. So it can get chipped, pretty easily if you're not careful or somebody's, not watching what they're doing. And so, you see that corner there didn't properly fill in on that casting. So instead, that's why we would have done like we did with the skull here. We've got one here that is 65D plastic coating brushed into the surface of the mold, and then the foam poured behind it with back pressure. And that makes sure that you get that nice durable skin on that surface. Does that make sense? And we have coatings, which we're going to talk about next, that can be brushed on to carve foam and stuff like that. But if you have something that has all this fine texture and detail, and you start brushing on coatings to hard coat it, you're going to muddy that detail as you're coating it. And so if you have a mold and you're making it in a mold anyways, it doesn't make any sense to cast it in foam first and then put the resin on after. If you have the mold, resin in the mold first, back it with foam, then you get the nice fine texture, fine detail, and the lightweight structure. This thing weighs maybe a pound and a half. It's super, super lightweight. All right. Now let's talk about coating materials and move some stuff out of the way here. Mess up. I'm not going to bother to mix any of the coatings right now, just because they're all going to cure so slowly that you wouldn't really get to see the finished goods. I'm just going to show you the finished goods. So, depending on what you're doing, zoom out a bit. We have stuff like, let's say you have a 3D printers and you're 3D printing an original model like this skull here, and you got those layer lines that build up on that skull, right? And you're trying to you want to make a mold off of this so that you can reproduce it quicker than what the printer can do, because you can pop a casting out every 15 minutes. Something like this might take 3 or 4 hours to print. So making a mold off of it's nice, but you also, if you're going to have it cleaned up and not have those layer lines, you want to, when you want to make that mold of a perfect smooth object rather than having to smooth those layer lines on every single casting. That's part of the reason you might make a mold off of a print anyway. So this piece has been half coated with our XTC 3D That's this stuff here. This is a basically it's even the skull on the box, right? This is a 2-to-1 epoxy coating that's brushed on. And if you have a print like this, it actually has pretty fine layer lines to begin with. Like one very thin, carefully applied coat does a really good job of glossing out and smoothing those lines and gives you a part that's ready to make a nice clean mold off of. If you have a rougher, coarser print, you might need to put a layer on, sand it, put another layer on, sand it. You don't want to glob too much of this coating on because then it'll run and you'll have these really difficult to clean off bits like that. So it's a lot easier to do thin layers and sand in between. So I've kind of done that on this Nuka-Cola bottle, those that are Fallout fans. So this one was printed as a vase in vase mode, which if you're, do printers, you've got, it will leave basically, it prints just the outline. So it left the bottom with some gaps and it left a little gap there and gaps on the top. So the top of it has a hole in it or a gap in it. So what I did was I filled the thing full of resin afterwards, made it solid. And then I used some epoxy clay to kind of sculpt in those contours that we're mixing, our freeform sculpt. And then I used the XTC to give a nice, perfect, shiny, glossy finish. You can still see the layer lines through that gloss, but it's a very polished finish from working on it like that. So this one was probably 2 layers sanded in between because it had a pretty fine resolution. It all just depends on the quality of the printer and what you're working with. If that makes sense. So that's one of the options for coating materials. Let's talk about some other ones. I've also used the XTC for this prop as well. So this is Lara Croft's axe from the new Tomb Raider games that started coming out. And so all this piece is foam core, layers of foam core sandwiched together, cut out with a stencil. And then I use the XTC 3D again, the epoxy coating, to build up layers of epoxy and sand and carve and shape this piece to that part. So there was no mold involved. This was completely hand built from a stencil. So I found a pattern online, printed it, glued it to pieces of foam core, which those of you who don't know what I'm talking about, foam core is this stuff, right? So it's like the cardboard on one side and foam in the middle and cardboard on the other side. It's like rigid poster board. And so this is a very useful medium for this. So I used a thinner version of it for this. So I did 3 layers, 1 for the center, 1 for each cutout side, and then it's just a matter of brushing on layers of epoxy, sanding, brushing on, sanding, so you build up and get this thing. This thing weighs maybe half a pound. It's super, super lightweight, but it's pretty durable too. It's not just gonna break on you. Same sort of thing going on here. These are the sword and axe from certain movie Serenity that River uses there at the end. It's the same sort of process using foam core. They use a stencil, print it out, foam core, carve it, shape it, and then this has actually got aluminum powder mixed into the resin, into the epoxy on the last few layers, and then sanded and shaped back to kind of do that effect, right? And then this is actually really just gaffer's tape wrapped around and painted with acrylic paint and then clear coated. So you can do really cool stuff with these coating materials that doesn't involve having to build a mold. And you might go this route if you only need one of these pieces, or you don't have an original to work from, and you need to make a mold anyways. You can make a master by hard coating stuff and using these epoxies to shape it and sand it and shape it and build it up. And then you can still make a mold off of these and then cast them in another material to produce them quicker. If that makes sense. So it's all in what your goal is and what you're trying to accomplish. So another option might be for bigger projects. Let's say you've got to do, a themed area. Our foam core out of the way. That epoxy coating is put on all sorts of stuff. It can be put on, cardboard as well. So this is just a cardboard piece of the cardboard box. It's off of a box of bandages, and then it's been brush coated with that epoxy, the XTC, and it's soaked in. There's a glossy finish on it, and you can build up layers, and you can build a master out of the cardboard and do that same sort of idea. So there's lots of ways to work with it. And on a bigger scale, I don't have a big example of it, but on a bigger scale, let's say you're let's say you've got a hot wire CNC cutter like that cuts polystyrene blocks, and this is a pretty common thing in a lot of themed environment shops is to cut polystyrene blocks, and then you get these big, large characters and things like that, or architectural elements. And then we have coating materials like our Epsilon series, Epsilon and Epsilon Pro, that are brushed on and then sanded between layers, and you get a hard, durable coating on that styrofoam. This is just a chunk of foam that we brush some onto, but that's the idea. And we also have, on a larger scale, I'm not going to drag the spray gun in here, but there's another product called Styrocoat, which comes in a cartridge. It's like an A to B cylinder with a mixing tube, and it drops into a big pneumatic gun, and it can be sprayed out of that system to hard coat large, foam objects. That's how you would do, big projects like that. Now that gun is like $800, and the material has to come in the cartridges, so it costs a bit more than the hand brushed on materials. But those are all viable options in that sort of situation, right? Now another material to talk about for coatings is I'll bring our brain back out here and we'll zoom in. So this is that flexible foam we were talking about, but it's been coated with Uracoat, which come on, focus. Uracoat is a brushed on polyurethane rubber that is easily pigmented. In this case, that pigment looks like blood, and it makes a very durable, abrasion resistant coating on the surface that is really, really useful. And it stays flexible, so if you've got a part that's flexible. Now this is a chunk of an example of a fake vine that we made that is actually made with some stuff we're going to use here in a minute, epoxy putty. This is actually a flexible, semi-rigid epoxy putty. So this stuff has a little bit of flex. It's pretty stiff though, but that's kind of the idea. It's a Shore 90A, so it's just a bit of stiffness. And then we use the Uracoat as a paint on it. And we were in some of the areas were shiny because we used, while it was shiny, we went ahead and slapped some of that moss from the craft store on there to glue it on there. And a lot of that's fallen off of this example piece as people have manhandled it. But that is the Uracoat coating material. And let's go ahead then. And may have any questions on the coatings. Again, you can always call. And those of you who are just joining, if you have questions that we didn't cover, or you think of something later, you can always call or email us, or come into our store if you're local in Dallas, which I don't think y'all are all in Austin, right? But you could drive up here if you really wanted to. We have a showroom with all sorts of cool stuff to look at and check out, and you're always welcome to ask us questions. We'll help you figure it out. We'll tell you if it's not a good idea and the reasons why, what you might try instead, that sort of thing, okay? So let's talk about, more specific to themed environments, common methods and materials for doing like fake rocks and fake trees, right? So we made this earlier. We applied our texture stamp material to this piece of fake bark to get our bark texture. So let's go ahead and peel that off of there. We got too early. Peel that off, and now that texture pad can be pressed into an epoxy clay that we're going to use here in a little while and applied to an armature to make fake trees and other stuff like that. All right, now this thing's still a little soft. It needs to finish curing a little bit, but you can see this is some of the fake epoxy putty that's been painted afterwards. So this is just pressed in as an example. That's the back side of it, and then that is with couple layers of acrylic paint, blacks and browns, just to give you that bark texture. So we're going to be mixing up here in a minute the Freeform Habitat Fire Safe, which is a two-part epoxy dough that is a neutral khaki color. It's going to look like this, and you mix it with the gray color, and we're going to use a folding powder here that's going to keep it from sticking to everything. That's why we have this plastic tub. And then this stuff is flame resistant. And so you make something with this and it is self-extinguishing. And that is a thing you'll probably run into a lot when you're engineering themed environments and theme parks and whatnot, is the materials need to be fire rated. The fire marshal does not want anything to burn. Now this stuff will, if you hold a torch to it, it will burn as long as that torch is going. But as soon as you take the torch away, it will put itself out in like 30 seconds or something like that, like self-extinguishing they call it. So that's what we're going to demo in a minute. There's also a black version of it that's used for aquariums, which the fire safe is an aquarium safe, but the black version is fire safe. Of course, you don't need it to be, is aquarium safe. You don't need it to be fire safe when it's underwater, right? So the black version of it is safe for aquariums, so you can go with coral reefs and things like that. But you can also use the flexible version, which this piece was made of, and actually this piece of bark is the flexible version as well, but it's very partially flexible. And I want to go switch cameras real quick to show you a vine thing we got here. So this, as it switches here, this piece up here, this fake vine, I made with that flexible version. So these little bits and stuff, it's all can be moved around. Animals can climb on this and sink their claws into it, but they can't really pick it away and tear it up. And so it's more suitable for that sort of application. It's in a zoo and they need a fake vine that they can, you know, bounce around and move and flex on, and it'd be that kind of consistency of that. And this was just made by creating this whole shape out of rope and knots and tying it together, and then coating it with that flexible epoxy. So you can see, I'll switch the camera back here. You can see this is just a test jump that I made that the color got wrong on, where you've got some just basic rope. You could also use steel cable if you need to. And you got this material flexes still with that rope inside of it. Now it's not going to flex like a right angle. If you go, you know, really hard, you can still crack it, but it's designed to have that semi-rigid sort of consistency. All right. Let's see. The other option that we're not going to mix up today either is concrete. So we have concrete specifically designed for this. So you can see this is another bark texture example here. This is our vertical mix concrete that is mixed with a polymer, and it can be practicing some stains on the back side of it here, but it can be easily painted, and it's lower cost than the epoxies. And very, very durable material still, very useful for fake rocks and things like that. I've got a piece here where we were starting to do I've got a partially made one here. So I've got, you can see the hardware cloth armature underneath. And this is just hardware cloth, and some people call it chicken wire, but this stuff is really a grid pattern. So it's technically hardware cloth. There's some scrap wood, and then I've got some zip ties that tighten things down inside there. It's just enough to give it some structure while you to apply the texture of the concrete to it. So this can be used to make big fake rocks relatively cheap. It's still relatively lightweight. It's concrete, but the density is actually pretty similar to the epoxy once it's done. So that's an example of some of that stuff. That said, let's go ahead and mix some of this epoxy, and we're going to apply it to that tree armature, and we will, you know, get through most of the demos, I think, for the day. If I don't answer a question, it's probably because I didn't see it pop up. So you might let me shout it out or ask it again, since I am kind of moving around, going back and forth here. All right. Freeform habitat. I'm going to zoom out. You can see this get mixed a little bit better. Now we have fresh flow because I put a hole in it on the flyer. The habitat is mixed 1-to-1, but it's extremely sticky in these containers. So first of all, you need to be wearing gloves because you do not want epoxy like this on directly on your skin. They are adhesive, and they are not necessarily going to put you in a hospital or anything like that. But the more often you get these materials on your skin directly, the more often, the more likely you are to develop a sensitivity to them. And if you become sensitized, it's like having an allergy to it. And then you can't really even be in the same room with the material when you can work, because you break out in hives and stuff like that. So just if you're planning to use materials, be safe. Don't get it all over your bare skin and stuff like that. So the folding powder is a mineral filler that looks like flour, and it's kind of used like flour if you consider this to be like mixing bread dough. So we're gonna dump in, a good amount of this. All right, and we're gonna basically make this bed of flour essentially for our clay to be mixed on for a habitat material. All right, that's been good. Let's go ahead and knife here. Cut these. Also tear off all the extra packaging label. Let's go ahead and open our part B. I'm going to zoom in real quick again just so you can see kind of the consistency of this stuff. All right. So if you were to, you can see it's very, very sticky, kind of like tar-like. And if you were to dip your hand in here and try to scoop it out with that, it's most likely going to pull the glove off and stay behind. And so you really don't want to go touch this without having some of the powder on your hands first. And scooping it out that way just really doesn't work well. So what you're going to do is get 2 stir sticks. And you're going to scoop the material out. And kind of, I like to like taffy spin it like that. And then you're going to dump it into one side of the box here, kind of start building up a pile. You're looking to make equal parts by volume. You can also weigh the material out if you wanted to put the whole thing on a scale, tear out the weight of the, the bucket and powder. And I'm doing this in this plastic tub so y'all can see, but you can use a piece of cardboard or cardboard box or something like that. You sealed up and that works fine too. Let's go ahead and scoop out a little bit more. Now, this is a kind of a material that does take a little practice. So if you have a project, you decide you need to use this, mix a small test batch first, get a feel for how it's done, because it can be very messy if you don't. All right, scoop out that much of the B. All right. I'm going to go ahead and throw these sticks away because I'm not going to be using a bit more right now. But you can definitely just keep the sticks with the bucket normally and keep using them as you make another batch. But I'm not going to be doing any more of this today. So I'm going to go ahead and put the lid back on that. And we'll start scooping out our part A, which the consistency is still very sticky, but it's different. All right. So we're going to try to eyeball and get close to exactly the same amount. We're going to scoop it out a little more paste-like and less, tar-like, but it will kind of cling to your gloves really bad as well. Pretty much, yeah. This whole process is a lot like mixing bread dough. So that's if you've done that, if you mixed dough before with flour to keep it from sticking to everything, it's very, very similar. I broke a stick. I got plenty of them. Pretty close there. I think that looks pretty good to me. We're going to call that equal. It can be kind of hard to gauge when they're not exactly the same pile. So if you really need it to be perfect, it does not hurt at all to weigh the material like I was talking about. All right, so those out of the way. Now, you can see that pretty well. The next step in this process is you're going to take some of this powder and you're going to sift it over both sides of the material. You want to keep the material coated in this powder while you're working with it. as well as keep your hands covered with it, your gloves. Again, no bare hands, but you want a little bit of this on your gloves because it kind of helps keep the material from sticking. As long as you got that on there, it doesn't stick to your gloves. So I can pick this stuff up and okay, right? A little bit's going to get through and stick to it. But that's the idea. This powder keeps it from clinging to your hands. And now we're going to go ahead and start folding it together. We'll sprinkle a bit more on there, fold it over, keep repeating that process. You only want to keep some underneath it. The other thing that the powder does is it thickens the material up. So as you're mixing it, it's going to get it to that clay-like consistency. We have stuff called Freeform Sculpt. You might see another product called Epoxy made by AIDS, which we also sell. And that's a two-part epoxy clay. It's very, very stiff, hard, clay-like consistency right off the bat. And so mixing it, it's crazy sticky like this, so it doesn't need the bread dough, but it's really stiff. And if you're mixing large quantities of it, it's really, really difficult. It'll kill your hands and your arms trying to mix large quantities of that stuff. So this stuff's very soft, it's very easy kneaded together and mixed, and that's why, but to get it to that consistency, it's gotta be all sticky and gooey like this. And so that's kind of the trade-off, and you need this powder to fold the material over and keep blending it together. So I kind of like to do, once it stops getting all kind of stringy like that, to keep folding it and push it down like that. Push down. Keep mixing it. And it's kind of tedious, but you can mix really big batches of this stuff. I've mixed batches that are, the size of like 2 basketballs. It's heavy, but like it's soft enough that you can just kind of work the material and keep mixing it. It's really not a big deal, It's getting pretty consistent now. I'm not seeing any major streaks, so I'm not paying attention to where it is on the camera there. Yeah, it's looking pretty good. It looks a little bit more. Try to kind of get that to stop flaking like that by mashing it together a little bit better. But it's gonna be all right, I think. Okay. So let's go ahead and zoom back out, and actually let's see here. Let's move our armature over here. Let's see what we do. All right, let's put it in the face. Let's try that. I think. All right. So we'll go ahead and take a bit of this clay and kind of roll it up. And if we work it too much without that powder, it's going to start sticking to our hands. So we want to be careful of that. So right now we're good. So what I'm going to do now, I'm going to take that, and there's areas that I haven't applied any stuff to. This is already partially done. It's kind of my demo tree. I did it partially applied at another demo I did. I'm just going to mash this into this armature, So this is, again, hardware cloth built armature that is kind of structurally stable. And ideally, you'd want to kind of do all this at the same time so that you don't have really bad, obvious seams. But we're going to go ahead and get all the areas we want to apply it to covered. So it's starting to stick to my fingers a little bit. I'm going to get a little more powder on them there. Get a fresh little batch down here because I missed the spot that I want a little bit extra on. And it doesn't have to be a hardware cloth armature. Of course, you can apply this stuff to anything. You could just build just a big wood armature. You could patch this directly onto a piece of rock or something. You could patch it onto onto a foam. If you're using a rough carving of foam, this can be coated on the foam as well. It can be used on just about anything. So like a popular thing for the aquariums, when people build aquariums with it, is to, they build a big elaborate thing out of PVC pipe. It's got like ins and outs and tunnels that they plumb all together. And they coat all that PVC pipe with this to kind of build and hide the fact that it is, but the fish can swim through all that and have that to explore. It's out of sight of the people looking at it, but it gives them kind of a hideaway that they like, but you have this nice aesthetically pleasing fake coral reef. If that makes sense. So they've got some videos on that y'all can check out too. So, you know, this live demo is great for, you know, being able to ask questions, which I'd still encourage y'all to do if you've got any. And it's great for, you know, getting a lot of stuff thrown at you at the same time. But we also have YouTube channels that have tons and tons of information, you know, and videos that you can watch that see specific processes in action. Now, you can go ahead and add some more powder to the surface like that if you need to. I might go ahead and change cameras. I might be able to see that a little bit better. See what it does. Okay, if y'all can see that, where I've applied this on there, it's not terribly good looking yet, but that's kind of the idea. We're just getting it applied into the area that we're gonna work the materials in this session, this batch. All right, down here, I got a little bit too much where it's kind of going through the hardware cloth. We wanna go ahead and smooth that out. And now, another thing to keep in mind with this, when you're working with any epoxy clay or putty, is brush glove there. Got a tear in it. The other best friend, we've talked about it all day today for cleaning up after yourself, you know, cleaning up the pigments, cleaning up residue from other, sorry, my hands are wet. Residue from spilt material or stuff left in the mixing containers, but denatured alcohol is, you know, the mold maker, you know, epoxy builder, it's your best friend. Okay, denatured, not isopropyl, which can work, but it kind of tears up. It doesn't like to go through sprayers like this. It tends to tear up, gum up the works. But denatured alcohol, you buy it from a hardware store. It's basically ethanol. It's essentially like Everclear in a gallon jug with bittering agent and poison in it, so you can't drink it. But it's the same stuff chemically otherwise. But it's going to be your best friend for smoothing these surfaces. So what you can do is spray the surface down with that alcohol, and then you can lubricate your hands to help spread the material and smooth it out, right? And then you can kind of help blend it into the existing texture that's on this piece. It'll help keep it from clinging to your gloves as well when you do this. Of course, I'm tearing my gloves on the sharp edges of the other part, but you know, it's kind of a trade-off there. So get that rough surface where we want it to be, how we want it to look. And then we'll go ahead and take our texture stamp we made earlier, which we got here, and we'll go ahead and spritz it down with a little bit of alcohol. It'll help act as a temporary release agent. And then we'll start pressing that in to our epoxy clay, like that. And so that's going to come away and leave that bark texture we just added. So a little bit of spritz of water on, or alcohol in there, which you can use water as well. You see, if I'm not careful here, I'm going to increase. You can kind of keep going back over it. We're using a texture like this over and over again. Now, it's not the same bark texture there. I was saying you can use water as well, which of course is generally free by comparison to the alcohol, but water doesn't dry very fast, right? It's going to make a puddle of epoxy contaminated water wherever you're working that you got to then deal with. Whereas the alcohol evaporates so fast that it doesn't make as big a mess on your project or in your work area. So I can even like bend this thing out and I can kind of sculpt specific areas if I need to. Say I need to blend this transition here a little bit. I can work those angles and then keep applying it. that. That's making sense to everybody. Kind of getting the idea. I'm not going to spend, another hour here doing this exactly perfectly. I think y'all get the gist. This is a little bit of an artistic form here. It does take a little bit of practice, a little bit of time and patience and blending. Just make sure I don't leave anything just not textured at all, though. So. Turn away from y'all real quick so I can see what we're doing. This is one of those specific kinds of projects that's not exactly ideal for a video, but any questions while I'm finishing this up real quick? Make it a little less just me mumbling. Any questions? Again, you're always welcome to ask later. You can always email us, call us. Always viable option. All right, so we now textured that. It could be better than that, but that's the general idea. We started to continue and add. We can always, if we screw something up, we can always add more over it after the fact and continue to build the thing up. So, I've obviously left bits and pieces here that need to be finished. We could always, if you decided we need to add another branch, you could drill into somewhere and, put some more armature, build it out, glue some on, and build another section. It can always be added to, it can always be worked on. And this can, of course, all be painted. I missed a spot over here. After the fact, with pretty much anything. You can paint it with, spray paint, acrylics, latex paint, just about anything is fine. Spray coatings, you can come up with, it's fine to put on here. All right, so there is that. Let's go ahead and move it out of the way. And I'll just show you real quick, kind of a finished example of something made like that. So for the Laura Croft axe that I made showing y'all, we've got made a little display stand for it. So this is a armature that I slapped together out of cardboard, some stir sticks, and a flat cardboard tube that some stuff got mailed to us with. And then I started applying, I waxed it, I believe, and then just to seal it up a little bit, and I started applying the Habitat Fire Safe to this and built it up. And so I sculpted the texture in there using the stone texture pads. And then this one, there's some light on it. You can actually see a little bit better there. This one has actually been done with iron oxide pigments. So rather than putting, mixing pigment into it or painting it, I decided to experiment, and I used our concrete pigment and mixed into the concrete to change the colors. I dusted it onto the sticky surface and pressed the texture pad in, and then kind of repeated it in blobs and colors to get this sort of model texture effect. And then I used, again, some of the Uracoat rubber up here to glue some of the moss vine stuff on there. It makes a relatively small portable example piece to hang my, the Laura Croft axe I made on there. That makes sense. All right, that was, I believe, most of the things I was planning to talk about today. I'd love to answer any more questions anybody has, or anything we didn't cover that you'd like more information about. It's be a great time, and if not, we can finish up whenever y'all are ready. Nobody?
I wanted to ask, what is your role with Reynolds?
What is my role with Reynolds? Is that what you asked?
Yeah.
So technically my job title is materials specialist. But really what it is, it's sales and technical support for the materials. So I mean, really the stuff sells itself. So it's just people come, hey, this is what I'm trying to do. What do I need? And I help them find the right materials, and I give them advice and give them kind of a rough how-to on how to use the materials, and then help them figure out what they did wrong. When, if you're new to the stuff, you're probably going to mess something up. I help you troubleshoot all that. So it's, kind of tech support for materials. But I also go and teach all the classes, you know, at other colleges locally. We kind of can go 120-mile radius from the store, so I don't usually get to go visit Austin or College Station or, you know, anywhere in South Texas in person. But here locally, this is all the colleges, and I do a live version of this demo, usually with a different set of castings on the second half of it that are more just generic for our art class, because I do a lot of sculpture classes. But yeah, you can kind of customize them and tailor them, kind of like this one. Then I also teach our basics of mold making and casting seminar that we normally have every other month when it's not a global pandemic, but those have all been canceled for the year, unfortunately. But yeah, does that answer the question?
Yes.
Any others? Stop away there.
Hi, you might have already mentioned this. I was only able to join around 6, but did you already give out your contact information if we have any questions or concerns, or just, we're also working on a project this semester, and we're going to be continuing to build our project over the next few semesters whenever we're able to put a haunted house on for real, whenever we're able to do that. So we were just wondering if you'd be open for any questions or advice if we ever run into.
Yeah, absolutely. I can, whatever's easier, I can either type that in chat here in just a minute, or I can have your professor email it out to everybody. That might be the easiest thing. That way everybody gets it for sure, so you don't have to remember to copy and paste it on the chat. But you can get a hold of us. If you want to email us, the easiest thing to do is just email dallas@reynoldsam.com, and that way it goes to the whole store, right? Not just me. So if I'm out, you know, if I've got a day off or something, somebody can answer your questions and help you. You know, so I'm happy to help, but you know, anybody here is technically savvy enough to answer your questions as well. And if you wanted to call us, our email address, hold on, or our phone number, I don't remember it off the top of my head, unfortunately. Grab a card real quick for that. Okay, our phone number would be 800-421-4378. But again, that can all be found on our website as well, which is reynoldsam.com. But yeah, oh, awesome, perfect.
You can send that email that you mentioned in the chat. That would be great, so we can.
Yeah, no problem. Let me type that in real quick. Let's see here.
But yeah, this was great. You had a great setup with the different camera angles and everything.
That is not correct. Sorry, hold on. This keyboard's messed up. Yeah, thank you. I appreciate that.
I wish we could come in person, or you could have come to UT in person to demonstrate, but sadly, this is a pretty cool opportunity for us to do.
Yeah, I mean, this is should be nice. I mean, was able to go 2 years ago, I believe, and do a demo down to the theater department down there. But we had our outside rep, Al, who goes and visits customers. That reynoldsam.com is our website, by the way. And if you go to that and you go scroll down to the bottom of it, you can actually find our YouTube channel as well, where we have a bunch of videos on different processes that you might want to check out as well.
Sounds good. Thank you.
You're welcome. Like I said, any other questions? And if not, we can sign off whenever y'all are ready.
Right. If there's no more questions for Phil, we're going to go ahead and do our organization announcements. So thank you so much, Phil, for joining us for the past couple.
You're welcome. Y'all have a good night.
Y'all have a good night as well.
Thank you, Phil.
You're welcome. Bye.